Circle geometry, rider number 2. The system being used, the thought process system, or the strategies come from this video on YouTube in the same series, and there is the address given for it. When doing geometric riders and proofs, you should know your theorems. Don't wait for the geometry to come to you. You need to ask yourself questions. Start with what you're finding or proving. Don't just look randomly at things. Don't just mark everything equal that you can see in the figure. If proving two angles equal, take one and find what it is equal to or what it combines with. Then compare it to the other. And if proving something about lines or shapes, ask, well, what if this is so? What if these lines are parallel? What if this is a cyclic quadrilateral? So here's example number 2. Don't worry to read right through everything. Just skim through. ED is a tangent to the circle, right? We know that. DA is a tangent to the circle. So DA is a tangent to this circle, and CD equals DF. So CD equals DF. Prove that LKBC is a cyclic quadrilateral. So our thought process, because it's a shape, we say, well, what if it is so? Well, we'd have the exterior angle equaling the interior opposite angle. K2 would have to be equal to C1. So let's prove that. So prove this. And then that means it will be a cyclic quadrilateral. So now we go into the strategy for proving two angles equal. Take one and find what it is equal to. What is K2 equal to? There's K2. Is equal to A2. Have a look at the tangent chord situation. Now we ask, well, is A2 equal to C1? What I'm trying to prove K2 equal to. The answer is yes, because it's exterior angle of a cyclic quad. That's the interior, there's the exterior angle. So therefore we have those two equal and we can do our proof. So we follow our thought process through. K2 equals A2, tan chord. A2 equals C1, exterior angle cyclic quad, which means we now have C1 and K2 equal. And that makes a cyclic quad by converse exterior angle cyclic quad. It's important that you put that converse there. The second part, prove that B2, that one there, equals LAD. That one there. So if proving two angles equal, take one, find what it's equal to or what it combines with. Now this one here has two angles, so that's likely to affect it. So I'm going to ask, well, what is B2 equal to? And B2 is equal to D4. Tan chord. There's the tangent chord set up. There's no reason why D4 would equal A1 and 2, though. But B2 is also equal to A1 and K2, exterior angle of a triangle. And if you have a look at that, that's quite useful because this angle here already has a dot. All we need is for that one to be a star, the same as that one. Is A1 and 2 equal to A1 plus K2? Well, A1 is common. Have a look. A1 is common, and A2 needs to be equal to K2, and it is by tan chord. So therefore we have the proof. So we're going to start by saying that B2 equals those two added, and that is part of that one already, which equals A1 plus A2. And that's quite a useful short way to do it. You see, A1, A1. Now all I've done is I've replaced K2 with A2, and I say tan chord because it means K2 is equal to A2. This is a tangent to the circle. That is a chord subtending this angle. And therefore B2 equals LAD, proof complete. The third part, prove that DE is parallel to LA. Well, this is about shapes and lines, so therefore we need to say, well, what if it is so? We're going to try to prove that those are parallel, so we say, what if they are parallel? So there's one diagram with them being parallel, and that's pointing something out pretty obvious there, that these two would have to be equal to one another. If it was so, D4 would equal A1 and 2. So I'm going to now try to prove that D4 equals A1 and 2. So we'll stop saying, well, what is D4 equal to? There's a tangent, there's a chord, and there's the angle subtended by the chord there. D4 is equal to B2, tan chord. Now we're going to ask, is B2 equal to A1 and 2? This one that was equal to, that we need equal to there. And of course, yes, because we've just proven it. So therefore we have D4 equals A1 and 2, and those are alternate, so it makes the lines parallel. So, our proof. D4 equals B2. D4 equals B2, tan chord. B2 equals A1 and 2, and that's proven. So D4 equals B2, which equals A1 and 2, so we now have D4 equal to A1 and 2. And those are alternate angles, so therefore the lines must be parallel, because we have alternate angles which are equal.